According to the Bureau of Labor Statistics, the mean amount of money spent by a household on alcohol in the US is $565 per year. So the null hypothesis, the average amount spent in a year by a household on alcohol is $565. The null is going to claim things didn't change. A church group wants to check this claim and took a random sample of 45 households and found that the mean for those 45 is 520 with a standard deviation of $167. Test the claim, and here it is, the key to the problem. Test the claim, test the church group's claim that the mean amount of money spent on alcohol per year is less than they specified. So the alternative, they're saying it's less than 565. And there's the claim. So if I reject the null hypothesis, I support the claim. If I fail to reject the null hypothesis, that means I do not support the claim. The test statistics, since they didn't give us the population standard deviation, the test statistics is going to be the t-distribution. And that's going to be x bar minus the mean divided by s over radical n. And that's going to be 520 minus 565 divided by 167 over square root of 45. And we know the drill. I'm going to throw that in my calculator. And I'm going to take parentheses 520 minus 565 close parentheses divided by 167 over the square root of 45. Negative 1.808. Negative 1.808. Make sure you copy that right from the calculator. It makes a big difference whether it's negative 1.08 or 1.8. And I'm going to copy that from the calculator as well to make sure that we have everything we need in case you look back at this. And there it is. Very good. Now, here we're supposed to pick which method we're going to use. We're going to do both. And in the next chapter, we're going to have, there are 3 methods. I'm going to do all 3 for you on every single problem. The p-value method. P-value method says, hey, no big deal. Figure out that what's the probability that t is less than negative 1.808. If that's probability, so this is negative 1.808, figure out what this area is. If this area, in this case, did they specify what alpha is? They didn't specify. We're going to use alpha to be 5%. If this probability is less than 5%, we're going to say we're going to reject the null hypothesis. If it's bigger than 5%, we fail to reject the null hypothesis. This probability is, and I'm going to get my calculator out, I'm going to go second distribution. We're looking for, and there it is, oops, CDF, the area from the negative. The upper is negative 1.808 degrees of freedom. They just say there were 45 people, so 44. And there's our answer. Now this probability, if this was two-sided, we would have concluded something totally different. That's why it's important to look at the claim. If they specify, it's up to you. I mean, if they specify, you have to follow. If they don't specify, you could use either. I suggest you stick with the sample. If the sample population is less than, go less than or greater than. But so this is 3.9%. If it's 3.9%, what does that mean? We reject the null hypothesis. That's how you do the p-value. Reject the null hypothesis. Let's do it using the critical region. Critical region, we say, all right, well, 5%, it's a single-sided. If this is 5%, right, Remember, this is a t-distribution. T-distribution can't figure out the area to the, it can only figure out an area to the left. So we're going to use symmetry. That is, we're going to go to an inverse distribution, and we're going to say, oh, to the left, that's perfect actually. It only finds the area to the left. So if we look at, so hey, on the last problem, I could have used the left instead. Now that I'm thinking about this, okay, here. I didn't mention that here. We could have used here. We could have used this 5% instead of using the 95%. Do you remember the last problem? Actually, it's still in the calculator. If I go second distribution, and if I go to an inverse t-distribution, if I use an area of 0.05, degrees of freedom on the last example was 39. Yeah, I haven't paid attention to that part. Right. Negative 1.68. There you go. So, hey, you learn something new every day. Kind of odd. I didn't see that until now. I could use my calculator and figure out what that area is. Inverse distribution, and we want inverse t-distribution. We want an area of 0.05. In this problem, they took 45, so 44 is the standard deviation. Give me that number, negative 1.68. Oh wait, they're matching. They're almost the same. They haven't changed. Actually, they changed slightly. This is 1.685. This is 1.680. But it's about the same thing, negative 1.68. It didn't change, so to speak. So let's copy that in the notes and see how that works. And there it is. So now, we would have also, if we were using the other method, we would have rejected the null hypothesis. There's no way of doing it. One way get reject, and the other one do not reject. So what are we going to conclude? Look at that. The claim is right there, and we rejected this. If we reject this, well, the data supports that claim right there. So we're going to say there is enough sample significant evidence to support the claim that the true mean amount of dollars spent on alcohol per year is less than $565 in the US. And the last example, we have the Instagram handles at @getfollowers claim that they can increase the number of followers someone has on Instagram. In March 2015, the mean number of followers for the US teen was 150. The claim that the null is going to say this average did not change. That's always the case. So a random sample of 12, n equal 12, they give it to us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 US teens with 150 followers were taken. The following is the number of followers which is normally distributed. Very good. I could use T or Z. These US teens had, after they paid at @getfollowers for their help, use a significance of 1% to determine whether @followers is effective at increasing the numbers of Instagram followers. So they're saying, would that increase to more than 150? That's what they're saying. Well, let's see. What do we have to do here? Well, we have to do the average and standard deviation. And what method we're going to use? We're going to use the p-value, and we're going to use the critical region, both. So let's go for the test statistics. I need the mean. Well, test statistics is t equal and the usual. Well, we have a problem. I don't know what that is. I know this is 150 and I know this is radical 12. I need to know what this is. Well, I'm gonna use list, if you recall. Second, no, not second. We're gonna use statistics, right? 1, edit, and list 1. We're gonna clear all of it. There you go. And we're gonna input 160, 200, 152, 150, 145, 151, 162, 158, 156, 149, 154, and 170. That's 12 of them. And I'm gonna quit. Now I'm gonna go to stat, calculate one variable. You want to use table 1? Yes. And give me those values. So from table 1, this is what I'm getting. It has a lot of information. I just want few of them. There it is. So this is from table 1. I need the average. The average is right there. 158.9. And the standard deviation is right there. 14.58. So I throw this in my calculator, and what do I get? Parentheses, 158.9 minus 150 divided by the square root of, I'm sorry, not the square root, I rushed. What was it? The mean was 14.58. The standard deviation divided by the square root of n. The square root of n was 12. No. Sorry, repeat. Does it work? There you go. 2.12. 2.11. 2.11. That's my test statistics. So far so good. And let me get that. Hopefully I didn't make a mistake anywhere, but if I did, you could trace it and figure out what I made a mistake on. And you know, it's the concept that matters. There it is. Now let's do the p-value. And I'm hoping by now you're really getting bored with this because you really get it. The p-value, what's the probability? Well, we're looking for what? Oh, and we forgot where was the claim. It says use 1% level security to determine whether it is effective in increasing. There's the claim. You try and see if it's effective. If you support the null hypothesis, you say, you know what, that doesn't change anything. That's useless. And if you reject the null hypothesis, then you say, yes, it is useful. Okay, so it's a single-sided, and it's a right side because it's greater than, right? And the test statistics gives it away, really. If it's positive, this is 0, it has to be right there. You're trying to figure out what that area is. Probability that t is greater than 2.11 is going to be, and here we are. Second distribution, we want, okay, what just happened? Distribution, we want 6. You could click 6, by the way, and we're going to go from 2.11. The upper is 1 e to the 99, and we want degrees of freedom. In this case they have 12, 1 less, 11. And tell me what that is. That is almost 3%. Now be careful how this plays. So this is roughly 2.92%. Remember, alpha in this case is 1%. So we're assuming less than 1% is not normal, not 5%. So we failed to reject the null hypothesis. Again, they changed alpha to 1%. If it was 5%, I would have rejected it. But here they're very picky. They only want to be 99% confident. So what if I wanted to use the critical region? Critical region, I would say, well, let's see. If you want 1%, right? Remember, I could only find the area to the left. So the area to the left is 99. Figure out the cutoff for the rejection region. Second distribution, inverse t distribution, at 0.99. Degrees of freedom were 11. Tell me where the cutoff is. The cutoff is 2.71. 2.71 is where you cut off the usual from the unusual. Anything in the rejection region is considered unusual. So the cutoff point for us is 2.71. And we look at the test statistics. It's 2.11. Isn't that to the left if this is 0? So fail to reject the null hypothesis. And that's very important. Why is that important? Because they're claiming, and of course they want you to pay them money to use such a service. And here's where normally, you know, non-profit organization comes in and say, you know what, wait a minute. You're charging people for service that doesn't change anything. There is not enough, but this is based on this sample. And that calls for further investigation, and you do it on wider audience and see if that works. So there is not enough sample evidence to support the claim that got followers is efficient at increasing the number of Instagram followers.